not a rant really, just some recommendations. So if you think about, so now many of these problems are solvable by hand with some effort, and some of you prefer to do that. So there will always be a blended, in this case, a blended kind of approach. I still like to use my notebooks as calculators. So instead of using your calculator as a calculator, so if you have to solve for CI surface, use fsolve. Oh my goodness, just spell it correctly. fsolve. There we go. You can use an fsolve function as illustrated last week, or if you have to solve a CI surface, and in some of the instances, it's not possible to do it by hand unless you use a trial and error kind of calculation. So you can actually solve that 7.1 by hand using a fixed point iteration loop. If you want to practice your numerical techniques, you can do it by hand. But I suggest keep your skills up so that you can at least, I can import NumPy from as NP or whatever. So write a bit and then use your fsolve as your calculators, or even if you want to do it in Excel to make it just easier to digest. So if I have this equation like in a KCAM, okay, let's just have it there. Already CI bulk minus CI surface is equal to an eta Ki dash CI surface squared. And now I have an equation for eta is equal to that I now have to substitute in there as a function of CI surface, and I have to solve my CI surface. It becomes so easy to make silly mistakes when you have to do the substitution. But when you work in Python, you just type those equations as they are and you substitute it in. So for me, it's easier to not make silly mistakes when I cross-substitute. Now, for instance, it's some horrible function of CIS, but I can type it in. So I guess my CIS, I calculate eta in my function. And then I have the right-hand side of my equation, right-hand side is equal to some function. And the left-hand side is equal to some function. And I return left-hand side, oh my word, minus right-hand side. Okay, so it's for me, and I know some of you I can see has got a serious Python allergy now, but it's really, when fsolve works beautifully is if I have a range of values for which I can, for these nonlinear equations, where I know my CIS must fall in this range. So that is definitely because I know my CI surface must be between 0 and CI bulk. I have an idea of where this will fall. Okay, so please, and maybe if you don't know where it will fall, set up this with don't just calculate this and say right-hand side minus left-hand side before you try to put it in a solver, and play around with initial values there and see what happens. Where will it converge before you put it into fsolve and you expect it to solve it? So I am not going to force you to use Python, but it is still, I mean, while we are now going to write the tests online and we are going to write the exam online, definitely. Why not use the tools that you've got available? Instead of forcing yourself to do lots of arithmetic by hand, that takes you lots of time. So I realize for some of you, this doesn't make sense at all. It's up to you, but my recommendation is to, when you do the TUTs, still, it will be a blended TUT therefore. So you will have lots of stuff written in paper, maybe, to get to your equations and to see, oh, I have to solve this, and this is my string of equations that I have to solve, especially when you do some prorating. But then please try to force yourselves to still use Python as your calculators. So that you can, it makes it easier to find mistakes, in my opinion. But okay, up to you therefore. Your long answer for a short question. Stop the